Alright guys, so I just wanted to start off this video. I want to try to get you guys as much help as possible. I just want to say that I apologize for not being there today. My household's had quite a bit of sickness, the flu, in the last 2 to 3 weeks, and I keep getting it, and just really trying to hunker down this weekend, on this long weekend, because I got another one. I got another fever over the weekend, so I'm just trying to give you guys an idea as to what I'm going through, and I am trying to get there. And I know that some of you are worried about this upcoming quiz and the test coming up. Just understand that I know that I'm not there. So I'm going to make some changes in the schedule to reflect, to make sure that I am there before you guys take any of these quizzes or tests, because I know that some of you are concerned about just making sure you know what you're doing, because you want to get a good grade on it and you want to do well. So I hear you, I understand, and again, I'm sorry I'm not there. I want to be there. As fun as we all think it is to sit at home when you're sick and you're sitting at home, or when you're taking care of your kid sitting at home, and you're sick and she's sick, it's tough. So I just want to start off the video with that. So what I am going to do today is I'm going to review the practice problems that are on our that are on Canvas that we've been going through. I know last class I had you guys go through them. I had you guys go through a practice quiz. That practice quiz is still up. I'm going to encourage you to just continue to take it, and you will see all of your answers and that kind of stuff. I have it set up that way. And like I said, if you find a question that's really giving you a hard time, you can't figure out how to do it, just shoot me an email. I'm gonna do my best to make sure that I get in on Thursday. Well, really tomorrow, so Wednesday. I'm gonna try to make sure that I'm here, hopefully. And if all goes well, that's what I'm shooting for. But if you need some sooner assistance on a problem you think I can help out with over an email, just shoot me an email. Again, I know I'm not there, so I appreciate all you guys working with me. Alright, so let's knock out a couple of these problems. So the first question we have is this guy. So this is about, honestly, it's as easy as it comes. I know that you're probably thinking to yourself, well, okay, but it really is. So what I'm going to do is I'm going to show you the problem so you know which one we're talking about, and then I'm going to slide it off the screen. I'm going to redraw it, and then I'm going to talk about it. So what this one says is that we have a let me change my stuff here. So it says we have a pneumatic piston with a pressure. Oops. Let's try this again. Come on. Alright. So a pneumatic piston with a pressure of 100 psi. Now, one thing I want to make note to you is on the actual problem, it doesn't say psi exactly. What it says is it says pound per inch squared. That is psi. Just for those of you, whenever you see this, that is psi. That's pressure. So that's the unit for pressure. So we have pressure right here at 100 psi, and then it also tells us it has been determined that 5 pounds of force is optimal to complete the task. So we have a force of 5 pounds. Alright, so we have 5 pounds of pressure. So the first question, so one thing I want you guys to keep in mind is all of these problems that we have, that come from these types of packets, they're very step by step. They're almost too step by step. Like we're We might ask you what the required area of the pneumatic piston is. Chances are we're not. We're going to ask you more of like the last question in the sequence. And you have to do all the steps leading up to it to get to that last answer. Okay? So the first question says, like, what's the required area? Well, we know in order to find area, what you can do is you can do, that was a terrible circle, F, P, and A. So if we cover up the F, if we cover up the A, because that's what they're asking for. If we cover up the A, we have an F and a P, so F over P. So we have 5 pounds over 100. And just to make sure my math is right for the video, I'm going to do it on my calculator, and I'm going to get an answer of 0.05 square inches. Okay, so that's my area. That's how much area I need. Now the next part of the question says, what's the required diameter? And this is where some people, I don't know why it gets some people tripped up, but it really does. Like, people have a really hard time, like you guys, some of you have a really hard time trying to figure out, like, what the question, how do you go from area to diameter? And I tell you to think about it. Like, if you draw your, or if you write down your area formula, the only area formula we really use is area equals pi r squared. Well, that doesn't give me diameter, but it certainly gives me radius, and if I find radius, I can find diameter. So we're going to take this 0.05, which is our area, and we're going to put it in there. 0.05 equals pi r squared. So we're going to do a quick changeover in color just to show. So we're going to divide by pi. 0.05 divided by pi, we get, and I'm going to round a little bit, 0.0159 equals r squared. So 0.0159 equals r squared. Then we need to square root that to get rid of it. Get rid of the square. And square root it. And we get 0.126 equals r. And then we're going to multiply by 2 because we need to go to diameter. 0.25 equals diameter. Alright, so with that question, that's pretty much how you do 1 and 2. And it'll get you through what you need to do. Okay, so the next question is doing a hydraulic lift system. It's got 2 hydraulic cylinders, 3 inches in diameter. Workers must determine how much the system is capable of lifting before deciding how much weight can be lifted safely. The system runs at a gauge pressure of 2,000 psi. So there again, a pound per square inch, psi. So what we're looking at is we have a pressure of 2,000. We have 2 cylinders, 3 inches in diameter. So I'm just going to jump right to the actual question I would ask you guys, and I'm just going to combine 3 and 4 because, again, I don't want to say that I'm not a fan of the way that they ask you the questions, but I just want to ask you the way that I'm going to ask you. So the way that I'm going to ask you is I'm just going to say, if the pressure is 2,000 psi and you have 2 cylinders, and again I apologize for my 2 cylinders that are 3 inches in diameter, I want to know how much force can I lift. So again, use our circle. F, P, and A. This time we're looking for F. So we have pressure, which we have. We need area. We don't have area directly, but we have the diameter. So again, we take our area equals pi r squared. So area equals pi 1.5 squared. Do a little bit of math. Where did I get the 1.5? I got the 1.5 because I took the 3 inches and I divided it by 2 because I went from the diameter to the radius. So 3 divided by 2, I get 1.5. 1.5 squared times pi. I get an area of 7.07 square inches. Now, I have 2 of those cylinders, so what I would do is I would multiply that number by 2, because I have 2 cylinders that are that size. So I really have an effective area, an area total we'll call it, of 14.14. Then we can do P times A. So 2,000 times 14. 2,000 times 14. So we get a force we can lift up 28,280 pounds. If we had 5 cylinders, we'd multiply this number by 5. If we had 10 cylinders, we'd multiply this number by 10. If we'd have 1 cylinder, we wouldn't multiply it at all. We would just use the 7.07. All right. Switch over here. Clear out this. So our area for each piston, number 3, was 7.07. How much is the system capable of lifting, which is number 4? 28,280 pounds is what we were looking for. Okay. So the next one looks like this. It says the gauge pressure of a pneumatic cylinder reads 20 psi. Let me stop real quick for a second. The last 2 problems we've done, we've used Pascal's law. Because we use Pascal's law, you don't have to do any conversions for absolutes. Because you're using Pascal's law, you don't have to do any conversions. All right. I'm saying that because the next couple questions we're going to have to. So it says gauge pressure in a pneumatic cylinder reads 20 psi when the volume is 30 inches cubed. The cylinder is compressed until the gauge reaches 60 psi. Assume standard atmospheric pressure. All right. So we're going to pull this off to the side. And it's going to say, so we have V1 at 30 cubic inches. We have P1, which is 20 psi. We have V2, which is what we're trying to find, and we have P2, which is 60 psi. So pretty much number 7 is the question I would ask you. It says, what is the volume in the cylinder after the gas is compressed? So I'm just asking you for V2. So because we're going to use Boyle's law, which is P1 times V1 equals P2 times V2, we're using one of those laws, which means we have to do conversions. So we have to convert pressures and temperatures. Well, we just have pressures here. So we add 14.7 to each one. So 14.7 plus 20 is 34.7 psi. That's the pressure we're going to use. we're going to add 14.7 psi to this one, and that's going to be 74.7 psi. Alright, so now we're just going to plug in what we know. So we have 34.7 times 30 equals 60. Oh, sorry, that's my fault there. Equals 74.7 times V2. So what we're going to do is we're going to multiply these two together first. So 34.7 times 30 and we're going to get 1041 equals 74.7 V2. Come down here and we're going to divide both sides by 74.7. And we're going to get a final volume, or volume 2, of 13.9 cubic inches. Now, in class, I told you that if pressure goes up in Boyle's law, which is this is what this is, if pressure goes up, volume goes down, or vice versa. So our pressure went up, which means our volume has to go down. Well, 13 is definitely less than 30. That's how you know at least you're in the right direction. All right. Okay. Next one looks like this. It says the air temperature in a 28 cubic inch container with a free sliding piston is initially measured at 45 degrees Fahrenheit. Temperature is raised to 200. What is the new volume of the container? So again, I'm just going to jump right down to number 10 because that's the question I would ask you. Meanwhile, we're going to answer 8 and 9 along the way. So, and again, you guys know how to use these videos. Feel free to pause when that thing is up. You have a copy of it if you need it as well. So, alright, so V1 is 28 cubic inches. T1 is 45 degrees Fahrenheit. V2, we don't know. T2 is 200 degrees Fahrenheit. So we are going to do, what we want to know is V2. So do you have a formula that has V's and T's in it? And your answer is yes. So it's V1 over T1 equals V2 over T2. All right. So that one is Charles' law. And if you're using Charles's law, then again, you have to convert pressures and temperatures into absolute. So the way we convert absolute pressure we talked about last time on the last problem, let's talk about how to convert absolute temperatures. You take Fahrenheit answers, Fahrenheit numbers, and you add 460 to them. So 460 plus 45 is 505 degrees Rankine. Degrees Rankine is just another unit. So we're going to do the same thing over here. So plus 460. So this is going to be 660 degrees Rankine. Those are the numbers you're going to use in your equation. So we're going to do 28 over 505 equals V2 over 660. Now, some people like to simplify this, and then I don't. I just cross multiply. So I'm going to do 28 times 660, and I'm going to get 18,480 equals 505 V2, and I'm going to divide both sides by 505, and I'm going to get 36.6 cubic inches for V2. Now, Charles's law says if temperature goes up, volume also goes up. If temperature goes down, volume goes down. So our temperature definitely went up. Our volume has to go up. 36 is definitely bigger than 28. So that's how we know we're at least in the right ballpark. All right. Jump over to the next one. Next one. It says a 60 cubic foot container or compressor tank contains a gauge pressure. Container has a gauge pressure of 160 psi and a temperature of 70 degrees Fahrenheit. The temperature after time decreases to the temperature after time sometime decreases to 40 degrees Fahrenheit. So temperature went from 70 to 40. Find the final pressure in the tank. Assume standard atmospheric pressure. So we have a few things, but this is the way that I built it. So we're given T1 at 70 degrees Fahrenheit. We're given P1 at 160 psi. You're also given temperature 2 at 40 degrees Fahrenheit. They're asking for pressure 2. Now they also give you V, which is 60 cubic foot. Well, when I see 2 T's and 2 V, or I'm sorry, 2 T's and 2 P's, that's the formula I'm going to use. So that formula is Gay-Lussac's law. And what Gay-Lussac's law says, it says pressure 1 over temperature 1 equals pressure 2 over temperature 2. So we don't even have to use that. Doesn't matter. Now, before we do this, we're using Gay-Lussac's law. That's another one of those 3 laws that we have to be in absolute temperature and absolute pressure. So what we're going to do is we have to convert. We have temperatures and we have pressures. So we have to convert everything. We're going to add 460 here. So 460 plus 70 is 460 plus 70. 530. 460 plus 40 is going to be 500. 160 plus 14.7 is 174.7 psi. Those are the numbers we have to use. So we're going to take our numbers. So 174.7 over 530 equals P2 over 500. Again, cross multiply. So 174.7 times 500. I get 87,350 equals 530 P2. Divide both sides by 530. And I get a P2 of 164.8 psi. Now, here's the thing I want to note. This pressure we have here is absolute pressure. In the question, they ask for absolute pressure. Now, if they asked for gauge pressure, you would have to subtract the initial 14.7 from this. So instead of 164, again, I'll just draw it on here for you. Maybe a different color just so you guys can see it. So this is absolute pressure. If we want gauge pressure, we would subtract 14.7. So instead of it being 164.8, it would be an answer of 150.1 psi. Now some people ask, well, how do I know which one I need to give? They will tell you, just like in the problem. They're telling you exactly what you need to do. Okay? All right. Jump to the next one. I think we have 2 more sets after this. Or, I guess 2 more sets including this. So the next one is a flow meter is attached to a hydraulic line that measures 12 gallons per minute. The line has an inside diameter of 1.5 inches. Find the flow velocity as the fluid passes the meter. Now, in the PowerPoint, they just skate over this concept. Real quick, one concept you really need to know. And it's what number 15 asks you. So, if I was there, what I would tell you, is that there are 231 cubic inches in a gallon. So let me write that down. So, there are 231 cubic inches in a gallon. In 1 gallon. So you're going to need that conversion for number 15. So they give you 12 gallons per minute. That's the flow rate, but it's in gallons per minute. And then they give you diameter, which is 1.5 inches. Now, we have a formula that looks like this. It's not Pascal's law, but I told you can make a circle. Q, V, and A. So number 17 is asking you, what's the flow velocity? So right here. So if we cover that up, we need a Q and we need an A. The problem is our Q and our A are in different units. And this isn't actually our A. That's our diameter. So we have to convert that into area. So again, back to that pi r squared nonsense we were doing earlier. So pi times 0.75, which is half of 1.5 squared, 0.75 squared times pi, and we get pi times 1. Sorry, mix that up just a little bit. I did that whole thing. So let me try to break that down. 0.75 squared is pi 0.5625, and then multiply that by pi, and we get an area of 1.767 square inches. So we're in inches. We're in square inches. The problem is this isn't in square inches. So that's where that conversion in number 15 asks you to do that. We have to make these two things like units. So we're going to take this conversion, and if there's 231 cubic inches in 1 gallon, how many are there in 12 gallons? Well, you take that 231 and you just multiply by 12. And that gives you how many? So that number, 12 gallons per minute in cubic inches per minute, is 2,772 cubic inches per minute, which is still our flow rate. So now we can do our thing. So V equals 2,772 divided by 1.767. So 2,772 divided by 1.767, and we get a velocity of 15,680.76. And if you're curious to know what the unit is, so this is per minute, and this is square inches. So this completely goes away. Two of them go away, so it's just left with one. So you're left with inches per minute, which is good because that's a velocity. All right. All right. Last one. Alright, so the last one. Hydraulic press is used to press fit two components together in an assembly process. The system must generate at least 775 pounds of force to perform the press fit. The cylinder at the input cylinder is pushed with a force of 250 pounds and an area of 30 square inches. The output cylinder can use up to 15 cylinders that are 30 square inches. How many cylinders are needed? So the first question asks you, what's the mechanical advantage? The reason it asks you what's the mechanical advantage is because that's what you can find. So you're given force input of 250 pounds. You're given force out of 775 pounds. To find mechanical advantage, the original PowerPoint for hydraulics said force out over force in. So 775 divided by 250. The answer is going to be mechanical advantage of 3.1. Now, the next question, there's a couple ways you can do it. So, basically how it works is you have an input cylinder right here. You have one input cylinder, that's 30 square inches. That's your input area. I'll call it area in. That's your area in. What you need to know is how much area out do you need over here in order to get to 3.1 is essentially what you're looking at. So, and then we can work from there. So the way that I would do it is I knowing what mechanical advantage is and what makes hydraulics have mechanical advantage, we know that the more area you have on your output, the more mechanical advantage you have. So what I would do is I would take our formula, and we can, I don't want to say make up a formula, but I know that I need 3.1 times more area on the output than I do on the input. So what I'm going to do is I'm going to do 3.1 times 30. So 3.1 times 30. And I'm going to get 93 square inches. So I need 93 square inches. Now, they say you have up to 15 cylinders here, and they're all 30 inches squared. So if you put one over here, my mechanical advantage would be 1, because it's 30 to 30. 30 divided by 30 is 1. If I add another 30-inch cylinder, Now I have 60 on my output, 30 on my input. 60 divided by 30 is a mechanical advantage of 2. You put another one over here, and you might be seeing where we're going. Every time you add a cylinder, you're increasing your mechanical advantage by 1. So right now we have a mechanical advantage of 3. We need a mechanical advantage of 3.1, which means we need to round up. So we need 4 cylinders on the output in order to get a mechanical advantage of 3.1. Okay? Like I said, if you have any questions, what I would highly recommend you do is go through some of those practice problems a few times. It shows you the answers. If you get stuck on one, feel free to email me. I can email, but I hope to see you guys soon. I hope to see you guys on Thursday. I'm really looking forward to getting back. Just do my best to try to keep you guys from not getting sick, and then also, what I'm trying to do right now is just trying to keep you guys informed. And like I said, I will post an update on the calendar. I will change the calendar, and I will also post an update, an announcement on what's going to happen with those quizzes, when they're going to be, and when the test is going to be, because I'm definitely going to make some changes to that, because I want to make sure that I get some actual hands-on time, face-to-face time with you guys before you take a quiz on this, because I know that some of you are concerned. Okay, so I look forward to seeing you guys Thursday, hopefully, fingers crossed, and we'll go from there. Thanks.